Hello friends, today we are going to discuss another topic of plasma physics, that is electrostatic ion cyclotron oscillation perpendicular to B field and lower high bit frequency. In the last video we have already discussed about electron oscillation perpendicular to B field and upper high bit frequency. So we will proceed in the same way as we did in last video. So here we are going to consider the oscillation, the direction of wave, propagation of wave due to the oscillation of ions. We will consider in x direction, and we will consider the magnetic field in b direction, in z direction. In this direction, magnetic field in z direction, and along x axis we will consider the propagation of wave. The oscillation takes place along x direction. Okay, so now in this case, like the previous case, we will consider the again same equation of motion. So in case of electron, we have taken this one, that mn del v e by del t plus ve dot del into ve, that is equal to minus en capital E plus ve cross b. So this was the equation of motion we have used in the last case in case of electron. So as now we are considering ions, so instead of small m, we are going to take capital M, which is mass of ion, and instead of ve we're gonna write vi. Okay, so and this minus will be plus in this case because charge of ion is positive. So here again vi. So this one is the equation of motion for ion. So let me rewrite it clearly. So what we have considered here, so this is the direction of the wave, and this is in z direction. Magnetic field is applied, B field is applied. So here equation of motion, is capital M small n del vi by del t plus vi dot del into vi is equal to en capital E plus vi cross b. So this is the equation of motion number 1. So again we are going to apply the linearization. So I'm not going to show the linearization method in details. So applying, so it is same as the last case, just instead of electron we have taken ions. Okay, so applying linearization. So if we apply the linearization method, then what will happen? So after application of linearization, we will get capital M del vi by del t is equal to minus E del phi 1. This is plus E vi 1 cross b naught. This is equation number 2. Okay, so here you see this E, this is negative potential of negative gradient of potential. Okay, so that's why we have used here del phi. We have considered a part of condition, so that's why we have written here phi 1. So now what we can do, so it must have 3 components, x, y and z. So if we split it into 3 components, then what we will get? Okay, as wave is propagating along x direction, hence separating the components, and also replacing del t by this minus I omega and del by ik, then we will get, so x component we will get minus I omega capital M Vix is equal to minus E I K phi 1 plus E V I Y plus, sorry, not plus here, it is B naught. This is suppose equation number 3. This is equation number 3, and then y component will be minus I omega capital M V I Y minus E I K phi 1 plus E V I Y, sorry, not V I Y, I have done a mistake here. So here it will be E Vix B naught. This is equation number 4. So then, and z component will be 0, okay, because wave is propagating along x-axis, so z component will be 0 minus I omega M V I Z, that's going to be equal to 0. Okay, so now what we're going to do from equation number 4, from this equation, from equation number 4, so we get from 4, equation number 4, what we're going to have, we're going to have VIY is equal to E B naught Vix by I omega capital M. So if you simplify this, then you will get this one. So this is suppose equation number 5. This is equation number 5. Now use this equation number 5 in equation number 3 in here. So this replace this VIY term by this value. Then what will happen? Then we will get what we're gonna do using 5 in 3. So we're gonna have minus I omega capital M Vix is equal to minus EI K phi 1 plus E square B naught square by I omega capital M Vix. So now so what we can do here, you can multiply I here and there with the numerator and denominator, then what will happen, this I will be here, then I will be here, and this plus sign will be minus. Okay, then let us simplify this. So what we're going to do, bring this term to this side, then take minus I Vx common, then what will happen, then you will get minus I Vix, then omega capital M minus E B naught whole square by omega capital M is equal to minus EI K phi 1. Now again you can take this omega M common. So if you do so, then what will happen, this term will be let me write it now. So now this is going to be minus I omega capital M Vix, and here it will be 1, then this is going to be omega square M square, so we can write here this is as a whole square. Okay, so we can write this, and you can see this is, so we know electron cyclotron frequency was omega c, that was E B naught by omega small m. So now here it is capital M, so it will be ion cyclotron frequency. So instead of small m, we have now capital M. So here we're gonna write, instead of omega, we're gonna write ohm C. So this represents ion cyclotron frequency. Okay, so now we can replace this term by omega C, sorry, ohm C. So this is what? This is nothing but ion cyclotron frequency. So now replace this term by this. So what will happen? Then you will get minus I omega capital M Vix 1 minus ohm C square by omega square. Sorry, here it should not be omega, only M. Okay, here only M. So an ion cyclotron frequency, electron cyclotron frequency was E B naught by small m, isn't it? So now this is equal to minus E I K phi 1. So now cancel what are the terms can be cancelled out. Okay, so here I minus I gone, and nothing, only this term gone. Okay, then if you simplify this, from here you will get Vix is equal to E K phi 1 by omega capital M into 1 minus ohm C square by omega square. So this is inverse. Okay, so similarly, if you consider this is the case of ions. Okay, this we have got this expression for ions. If you consider the case of electrons, then what will happen? So in case of electrons, instead of for electron, instead of Vix we used to write Vex. Okay, so then it will be, so instead of E there will be minus E because charge is negative in case of electron. So K phi 1, then omega, instead of capital M there will be small m. Okay, so 1 minus instead of ohm C there will be omega C, which is electron cyclotron frequency, by omega square. So this is inverse. Okay, so this is going to be the equation for electron, corresponding equation for electron. So now from equation of continuity, after application of the linearization condition, then you will get Ni1 n naught K by omega Vi1, and for electron you will get Ne1 is equal to n naught K omega Ve1. Okay, now you see, if you apply the plasma approximation, that means so we know plasma is nothing but it is quasi-neutral. Okay, and plasma will remain quasi-neutral if we apply the plasma approximation condition. That means if you consider this, so here you see, if you assume so applying plasma approximation, so that means we have to consider Ni is equal to Ne, that is equal to n, and Vix and Vi, that means velocity of electron and ions are same. Okay, then it will remain quasi-neutral, otherwise not. Okay, so if you take the condition of quasi-neutral case, if you take the quasi-neutral case, then you have to assume this, that they are moving with same velocity, electrons and ions. Okay, so if you apply this condition, then this Vix must be equal to Vex. Then if these two are equal, then we can say this right hand parts of these two equations are also equal. So then we can write, so therefore we can write, so let us write the these two sides of the equation. Then we can write here Ek phi 1 by omega capital M 1 minus ohm c square by omega c square whole inverse is equal to minus E k phi 1 by omega small m 1 minus omega c square by omega square and whole inverse. So from here you can cancel the terms, these terms, and also phi also will be cancelled. Then this omega also cancels. Okay, so from here if you simplify this, then what you're gonna have after simplification, you will get yes, so what we can do, minus m 1 minus omega c square by omega square is equal to capital M 1 minus ohm c square by omega square. So if you multiply both sides by omega square, then what you're gonna have, minus m omega square plus m omega c square capital M omega square minus capital M ohm c square. So, and if you simplify this, then what you can take here, omega square. Now write these two terms on the same side of the equal sign, and transfer this term to that side and take omega square common. Then what will happen, after taking omega square from this term and this term, from these two terms, what we're going to have, capital M plus small m within bracket, and on the other side we will get m omega c square plus capital M ohm c square. So now let us put the values of omega c square and ohm c square. What are the values? So omega c square will be E square b naught square by small m, and this one ohm c square is E square b naught square by capital M. If you put these two values, and putting these two values, you can take E square b naught square common from both the terms, and doing so, what we will get, so we will get omega square capital M plus M. So we will get E square b naught square 1 by M plus 1 by capital M. Okay, so what we have done, putting omega c square is equal to E square b naught square by small m, and ohm c square is equal to E square b naught square by capital M. Okay, so here you can see, if you simplify this, so E square b naught square, so on taking LCM, capital M small m, here we will get capital M plus small m. So omega square capital M plus small m, so these terms cancel. So from here what we're going to have, so final expression will be like this, omega square E b naught, E square b naught square can be written as E b naught into E b naught, and this term 1 by mn we can write separately. This is by m and this is by small m. So, and this is nothing but again ohm c is, this is ohm c, that is ion cyclotron frequency, and this is nothing but electron cyclotron frequency, that is omega c, and therefore we will get, so omega is equal to ohm c into omega c to the power half. Okay, so that is nothing but lower hybrid frequency. So this is called lower hybrid frequency. This is called lower hybrid frequency. So hope you have understood. So if you have understood and if you like my videos, then please share with your friends and subscribe the channel if you are new to my channel. Thank you for watching.